Again, welcome to Calculus class. In this lectures, we're going to discuss about Cartesian plane and the distance formula. This is our Unit 1, lecture number 1. This topic, again, is a Precalculus, but that will lead us to, again, a Calculus class. So our main objective is to learn how to plot points in a coordinate plane and also how to represent data graphically. Also, we are going to learn how to find the distance between 2 points in a coordinate plane. Also, how to find the midpoint of a line segment connecting 2 points, and how to translate points in a coordinate plane. So first, we start with the Cartesian plane. So here we said we can represent other pairs of real numbers by points in a plane called a rectangular coordinate system, or we use the term Cartesian plane. So again, the Cartesian plane consists of x and y axes. X is the horizontal axis and y is the vertical axis. And it's divided into 4, which we normally refer to as a quadrant. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So again, Cartesian plane is formed by using the two real numbers intersecting at the right angle as shown here. So the center of origin will be 0 when x and y equal to 0, and it's form again a right angle, 90 degree. So in quadrant 1, x values will be positive, y values also will be positive. But in quadrant 2, x values will be negative, y values will be positive. In quadrant 3, x value will be negative, also y value will be negative. Then in quadrant 4, x value will be positive and y value will be negative. So from this Cartesian plane, again, we can plot any points on it. So here we again said that the x coordinate represents the direct distance from y-axis to the point. So we can see the graph here. We have the x coordinate is horizontal. Again, y is vertical. So if we have a point, normally will consist of two values. The first value will be the x value and the y value will be the second value. And normally we use the term coordinates. So again, here we say the x coordinate will represent the directly distance from the y-axis. So from the y-axis, the direct distance up to the point. And the same thing applies to the y. So the direct distance from x-axis to the point will give us the y value. So the arrow is pointing, x is going towards right to the point, and y from the x-axis going up to the point. Now, using the rectangular coordinate system, it allows us to visualize the relationship between two variables. So as we can see the graph here, our variables will be the y-axis and x-axis. So for example, we want to find the relationship between income and, let's say, income and expenses. So income and expenses, we can make income as our x-axis and also expenses as y-axis. And we can plot the necessary values that we get within the two. So if a person makes an income of 20,000, maybe spend 15,000, another one make 5,000, spend 3,000. So we can see again the visualization, the pattern. So here, that's what we are saying here. Using a rectangular coordinate system, it allows us to visualize the relationship. So here we can visualize the relationship between income and expenses. Normally in college algebra, we can say one of the variable, which is the x-axis, will be the independent variable, because it's going to determine the y-axis, which will be the dependent variable. So in my example, if I make the income as a x-axis, it means it's my independent variable. Based on my income, I know how much I will spend. We normally don't want to spend beyond our income. So the income will determine, again, my expenses. So if I'm plotting a graph to find the relationship between the two, I will surely make the income as x-axis because it's going to determine the y-axis, which is my expenses. So we have an example here. And normally when we plot the points, we use the term scatter plot. So here, let's see, example we have here is for a number of years, 2000 to 2009. We say that the numbers E in millions of people of a private sector employees in the United States from 2000 through 2009 are shown below. So our goal is that we want to see what kind of relationship we can find from these two. Between 2000 to 2009, is the employees in United States private sector increase or decrease? So if we have the data for each of the years from 2000 to 2009, then we can visualize the data by plotting. So here, when we plot, this is what we see. So we saw that in 2000 up to 2003, the employee in the private sector in US was going down. Then after 2003, it went up to 2007. Then it went down somewhere around 2008 and 2009. So by plotting the data, we can visualize the relationship between people that were employed in the private sector in US and also with the years as the years go by between 2000 to 2009. So here we say, for instance, the first pair of values is represented by the year 2000, and we have 111 million people were employed in the private sector. Also, we should note that the break in the t-axis indicate that the numbers between 0 and 2000 have been omitted. Here we can see some break here. So again, we have omitted some few values. So we also, by using scatter plot, again, the previous graph is called a scatter plot. We'll plot the points on x and y axis to find the relationship. Also, there are so many different types of charts that we can use to visualize our data. So another example here is using the bar graph. So any software, for example, Excel, R, we have so many types of software that give us the capability to plot graphs. So here we have, again, a bar graph. Each bar represents the data for that year and the number of people employed in the private sector. So we can see 2000, somewhere around 111 million. Then in 2008, it's somewhere around 14 million plus. So next we move to the distance formula. Here we are going to learn how we can find the distance between 2 points. And this, we are assuming this is also a linear. And first we start with the Pythagorean Theorem. So by the Pythagorean Theorem, we normally apply it for a right triangle. A right triangle means one of the angles is 90 degrees. So here we have a right triangle. The side A and B is 90 degrees. So this is a right triangle. Now, when you know the right triangle, the Pythagorean theorem formula will be the side that is opposite to the right triangle, which is C, square equal to the two sides square summed together. So Pythagoras theorem will say A squared plus B squared equal to C squared. Normally we call the C side as hypotenuse, and it will be the largest side of the three sides. Always the hypotenuse is always opposite the angle 90 degrees. Now suppose we want to determine the distance d between 2 points. So here we are assuming we have 2 points, s1 and y1. Each point have a coordinate, which is s and y values. And also we have our second point is s2, y2 in a plane as shown here. So this is our 2 points, s1, y1, s2, y2. So where we have the d, we want to find the distance between the 2 points here. Now, in order to find the distance between these 2 points, we have to know the difference of the y coordinate and also the difference of the x coordinate. So we can see from the graph here, we have y1 and y2. Those are the points values. So the difference of y2 minus y1 is a vertical line here. Same thing applied to the difference of s2 minus s1 is the vertical line here. So in order to find the distance between these 2 points, you can see that we have come up with a hypotenuse concept, Pythagorean theorem. So the hypotenuse will be the side D. So here we are going to use the Pythagorean theorem to find it. So as we can see, first we plot our 2 points. The 2 points have 2 values, s1, y1, s2, y2. We want to find the distance between. In order to do this, we come up with a right triangle. Now, what is the distance from S2 to S1? It will be the difference of S2 and S1 to the point. So same thing, the distance between Y1 to Y2 will be the difference of Y2 minus Y1. So now D, since we have a right triangle on the side, D becomes our hypotenuse. So the formula to find the distance between 2 points, it will be y2 minus y1 all square plus s2 minus s1 all square, the square root, because the formula is d squared. So to find d, we find the square root of the answer. So let's see our example. As we said, we have d square will give us s2 minus s1 square plus y2 minus y1 square. This is using Pythagorean theorem. So d will give us square root of the values. So now we know the distance formula between any 2 points, if it's a linear straight line, it's always s2 minus s1 all square plus y2 minus y1 all square, the square root of it. So here we're going to do our example now. Here they say use the distance formula to show that the points 2, 1, 4, 0, and 5, 7 are vertices of a right triangle. So here we want to know if these 3 points can make up a right triangle. The only way we can know this is to plot the points on our Cartesian plane. Then we join all the points together and see if any of the side is a 90 degree. So we know 2, 1 means the first point is x, the second point is y, 4, 0 also the same. First point is the x, 4, y is 0. In the third one, the x is 5, y is 7. So we can just say that, okay, the first one is 0.1. So the coordinate will be s1, y1, 0.2, s2, y2, and the third one, 0.3, will be s3, y3. So we plot it. First, we plot our 5 and 7, and this is the point. We can see that x is 5, y is 7. And y is again horizontal, is somewhere around 7 before 8. And then y is 5. Then we also plot 2 and 1, which means x is 2, y is 1. Then we plot 4 and 0. Here, since y is 0, it will be 4 on the x-axis. So it's like s-intercept of y is 0. Then when we join all the points together, we came up And we saw that there is an angle, a right triangle between the point of 2 and 1 and 4 and 0. And here we just name the distances D1, D2, and D3. So here we can prove that yes, this is a right triangle because the line D2 and D1, their angle is 90 degrees. Now, how do we find the distance D1? So we use again our Pythagorean theorem. If I'm looking for D1, which is right here, I'm going to use these 2 points. So it will be 5 minus 2, the 2s values, all square, plus 7 minus 1, the y values, all square. Then the square root of it. Or we can go the opposite way. Instead of saying 5 minus 2, I can say 2 minus 5, which means I also have to say 1 minus 7. So we can say s2 minus s1 all square plus y2 minus y1. Now, if I say s1 minus s2, then also I have to say y1 minus y2 all square. So that's what we have here, 5 minus 2 all square plus 7 minus 1 all square. And by simplify this, we get 9 plus 36, and that will give us 45, the square root of 45, and we have the answer. So D2 also the same thing. And we use the x values, which is 4 and 0, then the y 2 and 1. Then the same thing applied to the D3. We use those 2 points. So we have 5 and 7, 4 and 0. And that will give us the answer. Now, because D1 squared plus D2 squared equal to 45 plus 5, and that will give us 50. So here we can apply the converse of Pythagorean theorem to conclude that the triangle must be a right triangle. And actually from that graph also we saw one side is 90 degrees. And when you have again a triangle, if one side of the triangle is 90 degrees, it means it's a right triangle. And the last subtopic is how do we find a midpoint? So here we'll go through a midpoint formula. That's a midpoint between 2 points. It's more or less like finding the average of something, the middle of 2 points. So here we said to find the midpoint of a line segment that joins 2 points in a coordinate plane, you can simply find the average values of the respective coordinates of the 2 endpoints. So kind of finding the average. So we can see here we have 2 points. So we have S1, Y1, S2, and Y2. So we take the S's, S1 plus S2, half of it, average. Then we also Y1 plus Y2 divided by 2. The point are S1 and Y1, S2 and Y2. So we take the middle, S1 plus S2 divided by 2, and each point have S and Y. So we have to do the same thing to Y, Y1 minus Y2 divided by 2. Or Y2 minus Y1. Addition. We are looking for the average, not distance. So it will be X1 plus S2 divided by 2. That will be my S point. Then Y1 plus Y2 divided by 2. So let's see an example. Here we apply it to a business application. Here we say the Ford Motor Company had annual sales of about 150 billion in 2007 and also about 106 billion in 2009. Without knowing any additional information, what will you estimate the 2008 annual sales to have been? We don't have any value no more. But this idea will bring us back to midpoint because we have 2007 to 2009. 2008 is between 2007 and 2009. So what we can do here is that if we had 2007 plus 2009 divided by 2, we will get 2008. So the same thing we're going to apply for the value 154 plus 106 divided by 2, and that will give us the average. And so that's the midpoint. The year is 2007 plus 2009 divided by 2. In 2007, we have 154. 2009, we have 106 billion. So Y section will be 154 plus 106 divided by 2. So in 2008, we have 130 billion dollars in sales. Again, here we are using the concept of midpoint. And this is the graph. So when we plot the scatter plot, again, the years will be the x-axis because the years will determine the number of sales. This year, what do we sell? Next year, what do we sell? So we plot the first 2007, 154 billion is our first point at the top. Then 2009, the sales was 106 billion. So the midpoint will be the middle of the straight line between the 2 points, which will be 2008 and 130. So we can also use the graph or scatter plot to solve this problem, or we can use the midpoint formula. Now the next section is how do we translate points in a plane? And translating points in a plane means we are moving the point from one position to another. So for example, if I have a point X and X is 2, and they say I should translate it to the right 5, it means I'll count up to 5 and I'll move it from 2 to 7. Or if they say we should move y-axis to the top or down, again, we do the calculation. So here we say the much of computer graphics consists of transformation of points in a coordinate plane. You know, in computer graphics, 3D concept, we do a lot of translation and scaling, etc. So one type of transformation is called a translation. At least we have 3 types of transformations in computer graphics. And the most common is the translation, moving an object from one location to another, or scaling. We change the scaling. Also, we can rotate, etc. So here, the figure shows here that we have a point already. So our point, let's assume our point is 1, 4, and we have to translate it, let's say 2 up or 3 down. So all we need to do is to count either 2 up or 2 down, etc. Now let's see the question. They said the figure shows the vertices of parallelogram. Find the vertices of parallelogram after it has been translated 4 units to the right and 2 units down. So this means 4 units to the right. We have to translate all the points. So I'll take the first point, 4 units to the right means I'll move it on the x-axis, 4 units. So from 1, it will be 5. Then 3, 6 means I'll move the 3. Now, when I move, remember again, a point have both x and y axis. So when I move it 4 units to the right and it's 5, I have to move it 2 units down. So if the y is 4, it becomes 2. So our new point will be at 5 and 2 instead of 1 and 4. If we are moving to the right, and when we're moving to the left, we subtract. Because moving to the left, we are reducing it. The same thing if we move y-axis up, we can add it to the actual value we have, how many units. And if we are moving it down, we subtract. So in this case, y is 4. They say we should move it 2 units down, so y becomes 2 now. So my new point for 1 and 4 become 5 and 2. My new point for 3 and 6, again, we move it 4 units, so it will be x will be 7 now. Down 6 will be 4. Down 2, so it will be 4. So that's the solution is given. As we said, to translate this vertex, just add 4 units to the right So we had 4. That's for the s. Then for the y, again, we subtract 2. So we can see if I have 1 and 0, it becomes 5 and negative 2 because I'm moving it down. So from 0, negative 1, negative 2. And the same thing if I have 3 and 2, it will become 7. I move it down 2, so 2 minus 2, 7 and 0. Next is 7, 3 plus 4, 7. 6 minus 2, I'm moving down, so 7, 4. And the last one, we have 1 and 4, so it will be 5 and 2. 4 minus 2. And this will be our new image. So we move it from the left to the right. So here we can see that it goes to the right. All the points go to the right by 4 units, then down by 2 units. So we can see the object goes down a little bit and to the right. So that will be the conclusion of this our lecture. So again, this is our first lectures in calculus, and we are starting with the basic topics first, which is more or less a pre-calculus. So here the first thing we learn about what is a Cartesian plane, how do we plot graphs and also visualize the graphs. We also talk about how we can find a distance between 2 points on a graph, linear graph, a straight line. Also, we talk about the concept of a midpoint also. So again, wish everybody the best and thank you for your time.